So welcome back, everyone. I'm recording in my office today, so I know sometimes the sound quality can be a bit wonky, but they're doing construction outside, so I'm hoping you all can hear me. So I'm hoping. We're going to go a little bit deeper into statistics, but I want you to understand when we talk about them, what's the use of the statistic? Why do we need to know it? And how can we apply it? So we're still in descriptive statistics. Remember, there's two bodies of statistical knowledge. Descriptive statistics are the body of knowledge that just basically describe. So what percentage of the population have education, below 12 years, above 12 years? What percentage have, these chronic conditions, whatever that is. We're just describing, we're not testing. The other branch of statistics that we use are called inferential, and that's hypothesis testing or testing data. So that's different, right? So right now we're just in description land, right? All we're doing is describing. And this is where the beauty of level of measurement, right? We talked about level of measurement, a nominal, ordinal, interval ratio. That's when it's really important because your level of measurement will predict what kind of descriptive measure that you use. So it's really important that we match these. And we're going to talk about central tendency, which are, things that you've been familiar with, like the mean, the median, and the mode. And then variability are things like what's the range and what's the standard deviation. So if you've heard these terms before, you may have even calculated them. Now you're going to understand when we apply them and when we use them in statistics. So again, last class, we looked at those frequency distributions, remember, ungrouped. We looked at the numbers of siblings that rural older adults had, and then we grouped them up. We looked at histograms, we looked at bar charts, we looked at a whole bunch of ways of visually representing data. And now we're going to look at, today, we're going to look at these two approaches, right? Two ways of describing data. We're going to talk about measures of central tendency, how close the data hang together, and measures of variability, how much the data scatter or how far apart the data are. So that's what we're focusing on today. And again, descriptive statistics in this case are univariate. All it means is we're looking at one variable. So we're looking at the variable of did you complete high school, yes or no, right? That's the only variable we're looking at. We're looking at, please, check the box to identify your, if you've had a chronic health condition and listing a health condition. Please, check the box that relates to your level of income, right? And their levels of income. So we're going to look at individual variables. And you all know what's your average, right? From when we're in school, we say, what's your average, your arithmetic average, or your mean score? And that is probably what we're most accustomed to, but we're going to learn that the mean is pretty sophisticated and you need interval ratio, or you need pretty high level data to address this measure of central tendency. We're going to talk about the median and the mode. And then the mean is a little bit tricky. So when we talk about distributions of data, if you have data that have outliers, remember the skew. If you have somebody who's extremely tall, somebody with an extremely high or low BMI, somebody with the high or low income, it's really going to affect your distribution. So you may not want to use the mean. So just a little lead in, but we're going to think about when each of these measures of central tendency, this trio, when we use the mode, when we use the median, and when we use the mean. And the mode, I think, is always cool, right? I think of demoda, which is like popular or what's of fashion. The mode is like, what's the most commonly occurring case? So if you have 5 people report health conditions, and somebody writes in cancer, somebody writes in traumatic brain injury, another person writes in cancer, somebody writes in diabetes, and somebody writes in chronic kidney disease, the mode, since two people mentioned cancer, that's the modal value. It's the most common or the most frequently appearing value. And when you have more than 5 people or 5 cases, you can have distributions that have multiple modes, right? So they can have numbers or cases repeat in clusters, and I'll show you that. And you can calculate the mode, or you can look at it from a frequency distribution, and we're going to do both, right? This is bimodal. So you see the picture, right? If you look at just half, could be the one mode. Here, for some reason, the data are bimodal. So here in the first case, with a single mode, you look at all the numbers, right? You scan the numbers. It's small enough, I'm sorry about that, that you can see 5 repeats. We have 5 repeating 3 times. Therefore, this is single mode, and the modal number is 5. Here we have the same distribution, but if you look carefully, 5 reappears and 15 reappears. So 5 and 15 appear twice. This would be bimodal, 5 and 15. If we had a case where there was another 30 here, the number 30, it would be trimodal, right? So this is just what are the most frequently appearing values. And the median is the point that cuts the distribution in half. The median is going to be your best friend if you have a skewed distribution. So if you're looking at income, and majority of people have income less than 50,000, but you have a few outliers who have annual income of like 300,000 a year, they're going to pull the mean. When you do the average, they're going to kind of mess up your average or the mean. So what you want to do when you have a case like that is you want to plot or hit the score and say, the average income might be 80,000, but if you look at the median income, where that cuts the distribution in half, the median income is going to be 60,000, which is more true of the population. So here's an example, right? If we have, let's see, 1, 2, 3, 4, 5, 6, 7. I'm sorry, 1, 2, 3, 4, 5, 6, 7, 8. 9, 10, 11. When you have an odd number of cases, it's very easy to do the median. The median is the middle case. So you can bracket off, right? 1, 2, 3, 4, 5 cases on each side. And you see this middle value is 7, right? Divides this distribution in half. Now, the mean or the average is what we use the most, but you can't do the average gender or the average ethnicity or the average political party. It doesn't match level of measurement. You can do the average test score. You can do the average BMI scores. You can do the average oxygen saturation. You know, whatever you're looking at, if it's a real number, you can do an average. So the mean is good for interval ratio level data, but the mean is affected. Remember the income. Everyone has an income less than 50,000. Somebody has an income of over 300,000 a year. So that will pull and skew your distribution, which will affect your mean. So whenever you have a distribution that has like scattered values, a lot of values that are clustered, but some values that are extreme in either high or low direction, then you say the mean is not the best. I'm going to use the median. And you do this all naturally, but this is the formal formula of what you do when you get a mean. You just add up all the individual scores and you divide by the total number of scores, right? Which you do. It's a more fancy way of listing it. Here's an example, right? This is a sample mean. These are the scores. You add the scores together. There are 11 numbers. You total, divide by 11. This is the mean. Right, 10.82. But I want you to think, again, as I said, that the median is good. The median is the best at reporting a summary measure when you have skew, right? Any skew, if you see a distribution like this or that, you need to use the median. right? Here we have mostly high values, but we have some low values that are pulling down. They would actually lower the mean. And here you have these high values, let's say income 300,000, they're increasing the average. So they're really kind of not capturing the true values that are within the distribution. So just think of it. Anytime you hear the word skew, I'm not using the mean, I'm using the median, right? Here's a table that I really like, and it'll give you a nice example of what level of data do you have, and then what measure of central tendency do you use? So give yourself a chance to look over the table, right? When you have nominal level variables, you can only say the mode, right? So if you look at political party, which is nominal, or you look at people defining gender, you can say that what's the most frequent political party affiliation? What's the most frequent or most common gender that's reported? That's all you can do. When we have ordinal level, you can do median, and I'll show you that. Ordinal level variables are high, medium, low. Please rate your level of satisfaction with your health. Would you say your health is excellent, very good, good, fair, poor? An interval ratio are real numbers. So this will help you when you're looking at what kind of statistic do I calculate. You go back and you say, okay, let me use this table and say the data are nominal, I use mode. The data are ordinal, I use median. The data are integral or ratio, I use mean. These are all central tendency. Later on, I'll add in the variation component. So central tendency looks at how things are clustered together. Variation looks at how far apart things are spread. So if you look at the average of a test score, you want to see where people cluster. If you look at the range of test scores, you're going to look at the lowest to the highest to the lowest, right? So these are the kind of, if you look at them as a relationship, these are the reverse of central tendency. So what is a good measure of variability or dispersion? It has to show you how spread out or where the scores lie, right? How far apart are the scores that you're seeing? So how do they relate? They are frenemies, right? Central tendency, how tight or how close the scores are, how close the data are together. Variation, variability, dispersion, how distant the data are from each other. And the range is one of the simplest ways that we calculate dispersion, variation, variability. And it's a simple formula. It's just the highest score minus the lowest score. So, you know, we could say that the range of scores on this test, on this measure, are from 1 to 30, right? It ranges from 1 to 30, and that full range is 29. So there's a wide range of scores. You could compare it to another. If you know somebody else repeated what you've done here and you see that the range is 5 or 10, you know that those scores are clustering in more tightly. 29 means more variability. If the range is 5, those scores are more tightly bound. Percentiles, I often think of like standardized testing, right? Like the SAT. If you're like me, I'm not a huge fan of standardized testing, but I hope you are. You look at the percentile, right? So you want to say, I'm in this percentile, and how do we calculate it? So if you get a percentile ranking of 15, right, you're going to say, how do I calculate that? What does it mean, right? So you want to look and say, what percentage of scores fall below this score of 15 on this test? 8 numbers line below it. The percentile rank is the number of values below the score you're interested in times 100. So there are here, right, in the 72.7 percentile, this is where you lie, right? That this many scores fall below what you're really scoring, right? So if you're at the 72, let's say 73rd percentile, what it really means, conversely, right, reversely, if you look at 73, let me do my math. So let's say that you are at the 73rd percentile. It means that 27, you're actually at the 20, in the 27%, if this is 73 of top scores. These are the ones that lie below you, the 72, or let's say 73, and then the 20, you're in the 27th percentile, which means you're in that top percentage. Right? If you're looking at quartiles, you just divide groups in half, and then you divide them in half again, and I'll show you here. So the example is, what quartile do I score in? Right? You divide the numbers in half. 7 divides, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry, 1, 2, 3, 4, 5, 6, 9, 10, 11. You divide the middle score, right? That will divide the quartiles in half. When you divide them in half, you get the second quartile. When you divide them each quartile again, you get the first and the third. So you can see where your score would fall in which quartile, right? And they're good for organizing your data. And variance, if you look at it, variability, we think of the standard deviation, and it really, if I want you to think of this relationship between the mean, which is this score, and the other scores. So in the variance, you're saying, or standard deviation, you're saying, how far do these scores, how far are they away from the mean, right? Smaller variance means that the scores are closer together. Larger variance means the scores are spread apart. So this is the standard deviation, and I'm sure you've used this when you did your statistics courses, but it's based on the theoretical normal distribution, right? And it tells you that when you go 1 standard deviation away from the sample mean, you're going to get 68% of cases. When you go 2 standard deviations out, you're going to get 95% of cases. And when you go further from the mean, all the way out to 3 standard deviations, you're going to get almost 100% or 99.7% of cases, right? So think about it. The standard deviation looks at how far cases are from the mean. And then this is what we looked at before, right? For nominal level variables, we don't really calculate a measure of variation or variability or spread. Ordinal, we use interquartile range. We use standard deviation for interval and ratio. And I think probably the most you're going to see is standard deviation. So now, if you think about how we're going to put this all together, I want you to look and take some time looking at this table, pick level of measurement, and pick summary statistic. Right, so they're here again, if we need a little wrap up, this is just another copy of the table. So here, if we look at this table, it's really interesting, right? They were looking at autism spectrum disorder reported by elopement status. So let's just look at all of these variables here. So we're looking at parental age, we're looking at child age, we're looking at gender, we're looking at race, we're looking at whether people self-define as Hispanic or Latinx, maternal education. Oops, sorry. We're looking at where people live, right? Physical setting. We're looking at current diagnoses. I'm sorry that it keeps flipping. So we can look at the level of measurement of each of these variables. And then we can think about the correct measure of central tendency. We don't really, well, we can see them and we can see variability and we can try to interpret them. So let's give them a look, right? Let's look at parental age. Age is a mean. Age gives the average and the standard deviation. If we look back, standard deviation and mean would indicate it's either interval or ratio, and it is. So giving one's age in years is interval ratio and can use the mean for central tendency and the standard deviation for a variation. Looking at, is someone identifying as female, it's nominal, right? Remember the binary, yes or no. Do you self-define as female? Yes, no. If so, that is nominal. All we can do is give percentage. So we know that for parents, the average age overall in this sample is 41.2 years. The standard deviation is 7. So they're, you know, a little bit under 40 and a little bit in the late 40s. And then women, we know that for the sample, about 95% are women, right? So it's a very female-driven sample, right? Whoop, whoop. We look at the children's age, right? Interval ratio, nominal. Child age, it's given the mean and standard deviation, it's number of years, it's interval ratio. The kids are about 10, right? Give or take 4 years. Race, and we'll talk a lot about the way that race is reified and how people take a construct like race or gender and kind of compile it. But I want you to think just for now that race and identifying as Hispanic, yes or no, these are nominal. So these are named variables. All we can do is look at the percentage that say that they identify as white, Black, or other, right? Very limited understanding and description of race and ethnicity, but this is what the authors did, so we'll look at it. The sample was 70%. Oh, numbers, I'm sorry. Let's see. Right. If we look, 90% white, right? White sample, very white, 6% Black, 5% Hispanic, I'm sorry, other. And in terms of identifying as Hispanic, we see that only 8% of the sample identifies as Hispanic. Why is it crucial to understand our demographics? Why is it crucial to understand these tables? Because if we want to generalize this study to other groups, we have to make sure that they are similar in these characteristics, otherwise the results won't apply. So let's keep going. Where is the sample living? Where you live, although some people do value it and say, you know, oh, you know, I live in the city, therefore I'm better than people in rural settings, or people in rural settings might say we're better than people who live in the city. That is just, you know, competition, but these are all nominal level variables. We're just describing where people live. And all we can do with nominal level variables is, you see, percent. So where do people mostly live? In this sample here, the overall sample, they live mostly, well, they're kind of distributed almost evenly into the suburban and small medium city, large city as well, and then rural. So if you were generalizing these to a rural sample, you'd have some trouble. Or if you're going to generalize this to a larger city, you may have some trouble, right? So you want to see, where do the sample live? And then you're looking at diagnoses. A current diagnosis is nominal, although you may rank diagnoses in some form of clinical difficulty or comparison. We cannot label these in terms of better or worse, right? So these are just names, and we're looking at what are the also the other clinical characteristics, and you can see how they lean out. I will show you this. We'll talk about p-value, but when we look at these, we're looking for anything less than 0.5. So a lot of these things are not really relevant, but don't worry. So right now, look through, and I want you to take some time, and you can slow down my kind of fast explanation, and I want you to really see, can you at all describe what these, what's going on in this table? What do the variables mean? What's the level of measurement, and what can you locate? So give it a shot, and then we will touch base in the next video.